Class, what's up? Welcome to our next video of section 4.2. This time we are going to focus on writing polynomials in factored form. Okay, so as we learned in the last video, one thing that can help us with our synthetic division, so we're not just completely guessing what our zeros are going to be, is we can make a list of PRZs. So that is the first thing. Now, PRZs, remember that we look at the constant and we look at the leading coefficient. That kind of gives us our hint about what we're going to put where. So, PRZs, a list of the factors of the constant. So, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. And then the denominator is always the list of factors of the excuse me, leading coefficient. So plus or minus 1, plus or minus 5. Okay? Now, we will keep going. We'll simplify this so we can actually get a nice list here. 1 divided by 1 is 1. 2 divided by 1. 5 divided by 1. 10 divided by 1. 1 divided by 5. 2 divided by 5, and I think that'll do it because 5 divided by 5 is a repeat and 10 divided by 5 is a repeat. Okay, so that's our list. We now know that any real zero is going to be one of these. So we start to test. We use synthetic division, right? Once we have our PRZs, I usually just start right at 1, okay? So I'm going to test 1, and I'm going to say that my coefficients of everything are 5, negative 22, negative 17, positive 10. So remember, we bring this 5 down. That's 5. What is this? Negative 17. Negative 17, negative 34. Not working. Okay. We'll cross that off. Let's try another. Let's try negative 1. If you wanted to, I guess you guys could just do all the positives first. I tend to just kind of work with my smallest numbers, though. So I'm going to go negative 1, and I'm going to redo this with a different 0. And let's see if this one works this time. Okay, so again, I bring this down. That's a 5. Excuse me. So negative 5, negative 27. It's positive 27. What is this? Positive 10, negative 10. Hey, there we go. Okay, we got ourselves a remainder that we were looking for. Okay, so here is the big takeaway. Now you know, remember that negative 1 is the 0, which means the factor is x plus 1. But anytime you get a remainder of 0, I want you to rewrite your function in factored form. Alright, so f of x, we can now, instead of having to write 5x cubed minus 22x squared minus 17x plus 10, we can start to factor this. This, we know, is going to be x plus 1, and then we have, remember this was cubed, so now this is squared. Alright, it always drops it drops a degree. 5x squared minus 27x plus 10. Alright, that is the whole idea of finding the list of PRZs. The whole idea of this is that, so once you can complete a synthetic division, you can rewrite it in factored form. Now, this isn't fully factored, we want to keep going. And I am here to tell you that if you want to keep going with synthetic division, by all means, you're welcome to do that. I just think that's silly. Okay, if I see this 5x squared minus 27x plus 10, I want to factor it. Now, some of us are at different places in our factoring ability, which I guess is okay, but I want us to all be all-stars at it. I know that the only way to get to 5x squared is 5x and x. That's the only possible way. Alright? Now, I need my outers and my inners to add to negative 27. Alright? So I'm thinking 25 and 2, which means I need this to be a 5. So when I do outsides, I get 25. And I need this to be 2. So when I do insides, this is 2. So 25, 2. Yep. And they both have to be minus. What's the other option here, guys? If you see 5x squared minus 27x plus 10, you're more than welcome to split the middle as well. You're more than welcome to split the middle. Now, the question, excuse me, oh my goodness, the question asks me to find all of the zeros. Well, that means that I would set 0 equal, and that means that I would get, that x is equal to -1, positive 2/5, and 5. Alright, so I should box a couple of these things. Let me box this too, because this is factored form. Alright. A couple things just to kind of take away. Notice, -1, 2/5, 5. Those are all in my list of PRZs. We know this, right? You weren't going to be able to get a 3 because 3 wasn't in our option of PRZs. Alright? So the other thing that I want you to take away from here, please make sure to read the question. If I'm asking for zeros, I want the zeros. If I want it written in factored form, well then I want the function. Alright? Now, lastly, it says to draw a graph of this polynomial. So let's do that. Maybe right here. I'll do one of these. And let's think through this a little bit. I need x-intercepts of -1, and 2/5, and 5. I should probably put some dots there, okay? The other thing I need to kind of keep in mind, guys, if you go back to the original, you can get the y-intercept, right? The y-intercept is positive 10. So that means I need to put right here at positive 10 my y-intercept. The last thing, if you look at the original or at your factored form, you can get the end behavior. End behavior, 5x cubed, or what's x times 5x times x? They're both 5x cubed. Alright, so we know that because the end behavior here is y equals 5x cubed, this should be doing what? This should be going down, up. Alright, so let's do it. Down through an x-intercept, up through the y-intercept, come grab this other x-intercept, and finally something like that. Okay, doesn't have to be beautiful, just a nice sketch including all of your points and the correct end behavior. Alright, so there is one example. Let's see what is going on the next page. Oop, we got another. Okay, so again, we are going to find a list of our PRZs. That is the first thing we should be doing. And I know that's going to be plus or minus, okay, so factors of 6. 1, plus or minus 2, plus or minus 3, plus or minus 6. Do I even need a denominator here, guys? Nope. My leading coefficient is 1, so I would put this over plus or minus 1, and then I would get the exact same thing. So don't do more work than you have to. Alright, let's see what's going on here. Okay, so again, I'm going to start with positive 1. It's just kind of my thing. And I know my coefficients are 1, -1, -7, 1, and 6. Alright, so I bring the 1 down, 1, 1, 0, 0, -7, -7, -6, -6, 0. Okay, this is good. We got a remainder of 0, that's what we wanted. Of course, my 1 was off the page. Okay, we got a remainder of 0. So we can start to write this in factored form. I now know that I can for sure write f of x, instead of as a 4th degree polynomial, I can write it as a linear factor, because I have x minus 1 is my linear factor here, multiplied by the quotient, or whatever the leftovers are. Okay, so be careful here. Remember, this was originally x to the fourth, which means we now have x cubed. X cubed, don't need an x squared, minus 7x minus 6. Now, be really careful. We don't have the tools to factor this yet. Okay, we don't have the tools to factor this yet. So what we would need to do is we would need to, in this case, continue with our synthetic division. Now I need to make a couple of notes here, or I want you guys to write down a couple of things here. First things first, must continue synthetic division. Why? Because we don't know how to factor x cubed minus 7x minus 6. Okay, the next thing I need you to write down, maybe we'll change colors here. 1 has not been exhausted. Exhausted yet. Okay, what I mean by that is just because we used a 1 and we got a correct 0 with a remainder and we were able to factor out an x minus 1, it doesn't mean that 1 is not going to be a factor again. Remember this idea of multiplicity? Okay, I want you to think multiplicity here. We could have another 0 at 1, or 1, I guess the 0 of 1 could have multiplicity of 2 or 3, etc. Okay, so just because you were able to factor out or synthetically divide out a 1 one time doesn't mean you can't do it again. So what we're going to do is we're going to immediately start again. But last note, work off of the new function. Okay, use the new coefficients. I do not want you guys to start over from the very beginning. Alright, we now know that we were able to factor part of this, so we have this function remaining that we need to factor. Do not go back to the original. Work off of the new coefficients. So that's going to look like this. Again, I'm going to try 1 again, but I'm going to use my leftover coefficients, or the quotient coefficients. So 1, 0, negative 7, negative 6. Let's see what happens. I bring this down 1. It's 1. This is 1. What do we got? 1, negative 6, negative 6. That's negative 12. Okay, that didn't work. That did not work. So now let's try. Now we can say that positive 1 is gone, and let's try negative 1. Alright, so let's go with negative 1, 1, 0, negative 7, negative 6. Bring it down. 1, negative 1, negative 1, 1, negative 6, positive 6, 0. Okay, there we go. That's what we wanted. Okay, this is good. This is really good because now we know f of x is, well, what did we have up from above? We already had x minus 1. And now we know that we were able to factor out an x plus 1. Okay, so now we have x plus 1. And now we have the remaining quotient to write. So x squared minus x minus 6. Hopefully you guys agree with me. We can factor that last little bit now. So let's make this easier on ourselves. Let's stop the synthetic division and let's just factor. Alright, we know we're going to have x and x. We need to find the factors of negative 6 that add to negative 1, and hopefully we agree that's minus 3 and plus 2. This is a good example of you being done, and by that I mean, oh, I'm really bad at drawing lines. It says in the original to write in factored form. It doesn't say to find the zeros, it says to write in factored form. So I have done it. Alright? Now, last thing we want to do, down at the bottom, let's draw a little quick graph. Nothing beautiful, but we know we have zeros at positive 1, negative, whoop, that's a negative 1, positive 3, and negative 2. We also know from our original equation that our y-intercept is 6. We know that our end behavior, I still didn't get it. Okay, our y-intercept is 6. We also know that our end behavior, x to the 4th, so we should be up. Alright, so I'm going to do a couple things in one. I know my y-intercept is at 6. I know I have to be up. So I'm going to go up through, and grab the y-intercept, then through, and end up. Okay? Again, how did I know this? None of these had extra multiplicity, right? These all had multiplicity of 1, so I was just going through, had to get the y-intercept, had to use the correct end behavior. Alright? Okay. What I would like to do right now is I want to skip the next problem. I think we're going to do the next problem in class just because my video is running a little long and I need to get to this last example so that you can see a new technique that might be required of you. Okay, so let's skip the third example, move to the fourth example, and let's see what's going on here. Okay? Okay. So, factor of the reals. Do I even need a list of PRZs here? I hope not. I have a plus or minus 1 are my only factors of the constant. Plus or minus 1 are my only factors of the leading coefficient. So really, guys, my PRZs, I only have plus or minus 1. Short list. Easy work, right? We'll see. Okay, so let's start with positive 1. My coefficients are 1, negative 3, negative 5, negative 1. Let's do it. Bring it down. 1, negative 2, negative 2, negative 7. No, this isn't working, right? No. Let's try negative 1. Maybe that'll work. 1, negative 3, negative 5, negative 1. Okay. 1. So this is a negative 1. Negative 4. Positive 4, negative 1, 1. Oh, okay now. Now we're in business. We got a remainder of 0, which means I have a factor. I now can rewrite f of x equals x plus 1, x squared minus 4x minus 1. Again, please remember, this degree has to go down. This gives me the coefficients of my new polynomial. But remember, the degree has to go down. And why is that? Because I'm taking out an x. I'm taking out an x from x cubed, which is going to leave me with x squared. Now here's the problem. Excuse me. When I look at this quadratic, I'm getting a little scared. Okay, I can't do that. I know that to factor this, I would have to find the factors of 1 that add to negative 4. Yeah, that's not something I can do, at least in my head. Alright, so the very last thing of this video that I need to reintroduce to you guys is your favorite and mine, the quadratic formula. Okay, so make a little note here. Oh. If you cannot factor, try quad form. Okay, if you cannot factor, try the quad form. Oh, you can't see that. There you go. Alright, so we're going to do that now. We're going to remember that the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, good. Got it. Now we need to plug in our values. Alright, this is what we're trying to factor or get the solutions for. So this will be my a, my b, and my c value. So let's see here. X is equal to, my b value is negative 4, so this will be positive 4 plus or minus the square root of b squared, 16, minus 4 times 1 times negative 1 all over 2. All right, 2 times 1. All right, if I keep going with this, I keep trying to simplify this a little bit more. X equals, let's see here, 4 plus or minus, this will become positive, so I have the square root of 20 over 2. I can keep going. X is equal to 4 plus or minus 2 root 5 all over 2. Please ask me in class if you don't remember. Actually, never mind, I'll just talk now. Remember that if you have the square root of 20, you can take out a square root 4, or you can split up 20 into 4 and 5, and the square root of 4 is 2. So we can simplify that. And then here's the last part that I think some people maybe get confused on, and I like to draw hearts for this. Remember that when you have multiple pieces divided by the same denominator, you can kind of split it up, kind of do one of these, and like these, kind of makes a nice little heart. Alright, so what I'm going to say here is I'm actually going to say that x is equal to, well, 4 divided by 2 is 2, plus or minus 2 root 5 over 2 is just root 5. Okay? So, just to kind of help us out here, because we have to still write this over, or write this in factored form, I'm going to split this up. I'm going to say 2 plus root 5 and 2 minus root 5. And what I want you to now know is that these are zeros, right? These are zeros. We can use these. We can actually put them into our factored form. And that's what we're going to do right now. I'm going to bring down what I had before. So f of x equals x plus 1, x squared minus 4x minus 1. And what I'm going to now say, guys, is that we can write this differently. We can write this in fully factored form. The x plus 1, of course, stays. We didn't change anything with that when we used quadratic formula. But I now have zeros. Okay, I now have zeros. So I have x and x. And what you need to remember, and this goes back to excuse me, our synthetic division. Remember that if you have a 0 of -1, that leads to a factor of +1. It's kind of always the opposite of what it looks. So my zeros here are going to be, or if my zeros here are positive 2 plus root 5, I'm going to be minus 2 minus root 5, and then minus 2 plus root 5. You have to subtract them both. So when you subtract 2 and subtract root 5, you get minus minus. When you subtract 2 and minus negative root 5, you get minus plus. So now we have a fully factored form of that original function. To finish, let's draw a quick graph. Maybe not so quick, but let's think about it for a second here. Okay, the nice, easy 0 at -1, that's great, love it. We have some work to do, or just a little bit of thinking in terms of these other zeros. Please keep in mind, guys, radical 5. Radical 5 has to be a little bit bigger than radical 4, right? So if you take 2 and you subtract something that's a little bit bigger than radical 5, what do you think you're going to what do you think you're going to get? Yeah, you're going to get a decimal that's just a little bit negative. Okay, this is just I'm trying to think. I'm not even exactly sure. 2 point. Let's see here. Let's see here. I'm just trying to. Okay. If I have a radical 5, and I know that, so this is kind of my thought process here. Okay, radical 5 has to be between radical 4 and radical 9. So it has to be between 2 and 3. So if I'm taking 2 and I'm subtracting it, I know that that 0 is going to be somewhere right in between. So I'm going to say that that's 2 minus radical 5. And then I can kind of think the same way, except now I'm going to add it, so it's going to be a little bit over 4. So I don't know, 1, 2, 3, 4, maybe something like this, and I can say that that's 2 plus root 5. And then I pretty much, oh my gosh, I'm off the graph. I'm just a mess to end this video. Okay, I have my zeros. If I go back up to the top, I can get my y-intercept is -1. and I know that my end behavior is down to up because it is y equals x cubed, or down to up. So when I take all of that into consideration, I start down, I have to drop back immediately to pick up my y-intercept. I go through, I go through, I go through, and I go up to finish my graph. Alright, sorry about that fumbling of this explanation here. Hopefully you guys understood it. If not, we can absolutely talk about it in class tomorrow. Alright, I hope you have a great day, and I will see you next time.